Hey, hi everyone. Good evening. Hope everyone is doing well.
Good evening, sir.
So, as friends, as promised, every week we have this presentation on the projects that our students, our interns are doing. And as part of this week, we have our. Good evening. Hope everyone is doing well. Sorry about that. So, we have Sushant and Ashwin who have worked on pricing analytics for agricultural market. So the current scenario in the commodity world, the vegetables, the fruits, right? So the prices are really fluctuating a lot. Now, to provide a platform for our farmers, there is this client of ours who developed an application. It's completely into agricultural market. So they have this application where they try to capture the commodity prices and they forecast on what is the best price that can be given to the farmers so that they can sell their crop or they can sell their yield for a better profits in a given state, given area. Monday to Monday, there will be a slight fluctuations in the prices. So we are capturing those prices and providing the best solution, best price for our farmers. So that is a project, and I would like to introduce Ashwin and Sushant, who are the team members who have developed this application. And Ashwin will start off the presentation. And there you go. Ashwin, please go ahead.
Okay, sir. A very good evening to all. My name is Ashwin. I would like to thank Sharat sir for sponsoring our project, Pricing Analytics for Agri Market, Amit Jaiswal for being project advisor, my team, and 360 Digit EMG for giving me this wonderful opportunity. Let's quickly go into the project. Introduction. First, our business problem. Depending upon the geographical conditions, global conditions, seasonal changes, and supply and demand, the price of the agriculture commodity varies. In this project, we have to predict the price of agriculture commodities for a particular date to favor the farmers and customers. To achieve this, we have applied forecasting technique to predict the price of commodity agriculture commodities. We have forecasted the commodity price in two types. One is weekly forecasting, and another one is monthly price forecasting, and another one is forecasting the prices of commodities with respect to market as per the markets. In weekly forecasting, the price of commodity will be predicted for next week, whereas in monthly forecasting technique, the price of commodity predicted for the next month. In market wise forecasting, the price of the commodities will be predicted as per the requirement, whether it is weekly or monthly. Assumptions. We did research on so many websites for the data, and finally we have considered this agrimarknet website, and we have covered 3 commodities from the agrimarknet website, like potato, onion, cabbage, from Kolkata district. We have selected Kolkata as our region, and from that Kolkata region we have covered these 3 commodities: potato, onion, cabbage. Technical stacks. We have used Python programming language in this project. In this Python language itself, we have done all the things. And Selenium WebDriver. This Selenium WebDriver, it is a package. It is used for the purpose of web scraping, and we have used this MySQL for the creation of a database and to store the data in database. And HTML, we created web pages in HTML, which will be which are used at the time of deployment. And finally, we have deployed our model, developed model by using Flask architecture. We have struggled a lot at the beginning and ending of this project, that is at the time of web scraping and at the time of deployment. We have performed web scraping on Agri website and stored data in database. From that database, we have imported data. We have imported data and we have performed this data cleansing, EDA, model development, model deployment in the sequential manner. And to add these, adding with these things, and one more updating, one more button is added to these things. Whenever you want to update the data, you can go for this data update and data preparation. We prepared a data set by collecting historical data of 4 years from 2017 to 2020 by using web scraping technique with the Selenium WebDriver, which is a package in Python. This prepared data set consists of district name, market, commodity, variety, grade, and model price of specified commodities. As I earlier said, we are discussing about 3 commodities in Kolkata, that is potato, onion, cabbage. Descriptive analysis. After importing data and performing data cleansing, EDA, we got these plots. From box plot, we can observe that the price of potato in Bara Bazar market, that is, it is the price of the potato commodity is high in 2020 and it is low in 2017. At the same time, the average prices, monthly average prices of potato, if you observe the time series plot, we can make a point that the monthly average prices of potato are like this. And going to the moving average plot, the average price value of the potato commodity will be shown with this pink color line. And from the seasonal decomposed plot, we can observe the raw data, that is observed data, and trend, seasonality, residual. Residual is nothing but noise. Okay. In this, trend is in between from 1000 to 2000 and seasonality is in between -10 to 10, and the noise component is around from -500 to 500. It is this analysis for onion commodity. From the box plot, we can observe the minimum and maximum prices of onion from Shillakoli market in Kolkata, and monthly average prices of onion and moving average plot, and the average price of onion with pink color line. And from this seasonal decomposition plot, the trend is varies in between 1750 to 2250, and seasonality is varying from 0 to 5, and noise component residual is from 0 to 250. And it is the analysis of cabbage. From the box plot, we can observe the minimum and maximum prices from time series plots, monthly average prices, and average price of cabbage in moving average plot, and from seasonal decomposition plot we can observe trend, seasonality, residual. Trend is from 1000 to 3000 and seasonality is from -25 to 0. Noise component is from -500 to 500. Predictive analysis. After performing the forecasting, we have predicted the price of potato, onion, cabbage, and the uh, raw data, which is shown with blue color line, and the forecasted prices, original prices or historical data prices are shown with this blue color line, and forecasted prices are shown with a brown color line. And the predicted prices of potato of Hara Bazaar are compared with the next it is for weekly forecasting, and the predicted prices of potato are compared with the virgin next week prices to check whether our program is working or not. And this is the predictive model for cabbage. We can observe the forecasting prices of cabbage with this forecasting plots, and these are the prediction of prices of cabbage on weekly analysis. These are the graphs of cabbage forecasting prices. These are the prediction prices of cabbage. These are the deployment. At the time of deployment, we used HTML pages. These are the HTML pages which we have deployed in Flask. It is the home page. When we try to access this page, this page will be shown, and here are two buttons will appear. One is to update the data. One is for prediction. If you select the update data, the data will be updated, and if you select the prediction button, the web page will be like this. And if you select those elements, district, commodity, and market, and type of prediction, you can get the forecasting or predicted prices for specified commodity. And this is the final predicted price of commodity. And this deployment the code forecasting model will be explained by my teammate Sushant. And these are the future plans. We can increase the number of commodities, and we can go for large number of regions or markets. We can improve the model to forecast for different regions and throughout the India. Thank you. My friend, my teammate Sushant will explain you code.
Okay. Good evening, everyone. My name is Sushant, and I'm teammate of Ashwin. We have previously worked on this project, and I'll share my screen. This is the deployment part of our project. We have mainly provided two buttons in this page. Mainly, it is update data, which will update the data that is present in the SQL. It will directly take the latest date in the SQL, and it will be given as input to the web scraping part. And From that date till today's date, all the data will be downloaded using this update data button. And the market wise prediction, here we will go to directly the second page that Ashwin has shown you in the PPT. Here, I'll show you the SQL part. This is the previously updated SQL part, and we'll check the max date and minimum date. As you can see, the maximum date is October 6th, and the minimum date is January 1st of 2016 year. We have collected 4 years of data of these three commodities, which is potato, cabbage, and onion, and we have performed prediction using ARIMA model. And this is the deployment code. Here we will directly run the app.py file, which will deploy the web page. As you can see here, there is a server. We will directly open it into the browser. As you can see here, now we will update the data once again so that you guys will get a clear idea of how this one is working. The data has been successfully updated in the SQL database. So now we'll go to the market price prediction. When we click that button, we will directly go to this page, and here we need to select the district, commodity, market, and type of prediction that we want. Basically, we have included two types of prediction, that is weekly and monthly. Weekly will give us 10 days of forecasting, and the monthly will give us 30 days of forecasting. Now we'll select the district as Kolkata, commodity as potato, and market as Barapazar, and the prediction type, we'll take it as weekly. Now when we run this program, it will directly show us the output. These are the predicted values of next weeks. And now I'll show you the code of this web scraping. Here, I'll show it step by step. Firstly, we are clearing all the previously downloaded files that are in the downloads folder. We have specified a particular path to download all the folders so that there won't be any mixing of previous files. There will be previous files that have been downloaded through the browser, right? So we have specified a path and a separate folder where it will directly download all these files into that folder whenever we'll run this program. So firstly, we are clearing all these folders. As you can see, all the contents of this folder have been deleted. And now we'll go to the web scraping part. We have used Selenium package, and using Chrome WebDriver, we have automated the process of downloading all the data that is required. Here, these are the here we'll select all the selections, that is West Bengal state and West Bengal state, Kolkata district, and the commodities that are required. After this, as you can see, the files are being downloaded here, and they will directly go into this downloads folder. After all these downloads will completed, when all these downloads will complete, we'll merge them into a single file. It will take a minute to complete all the downloads. Here all the files have been downloaded, the commodities that are required. We can specify which commodities are required. So we have specified commodities of potato, cabbage, and onion. These and also apple and mango. We have basically chosen these three commodities because of the data was very consistent. And now we are merging the files. We have used pandas and glob for accessing the files in the folder. Now, all the data is been read into a data frame, and here we are converting it into a single CSV file here. And also we are removing all the NA values. I mean, all the missing data, no data found cells will be there in our data while downloading. So we are removing them, and we are replacing them with new data. And also there won't be any state name that will be downloaded. While downloading, there won't be any state name. So we have we have inputted a new column where it will give us West Bengal state name. And after this, if anyone is running this code for the first time in their systems, we have directly created a database. We can create a database by running this code. If the data is already there, if the database is already there, then we can directly upload the data. We can append the data. We are not downloading all the 4 years of data from 2016. Just we are updating the data. So directly the data which is downloaded freshly will be directly appended to the data that is already existing in our SQL. As you can see here, the data is being appended to the existing data in the database. After this is the database that is being uploaded. We have imported all the data from 2016 till current date. So this is the data frame. And now we will extract the commodities that are required. That is potato, cabbage, and other one. So basically we'll do one by one. So firstly, we'll take the potatoes data of Barabazar market and Kolkata district. As you can see here, the data is being, we have all the information of the data. Now we are selecting that is required, all the commodities. Now we are doing the pre-processing. Basically, the data won't be consistent, right? The dates will be missing. So we have imputed the data, missing dates. And that is the pre-processing part. And next we'll directly extract the month and year. Since the data in the database, all the dates will be saved, right? So we'll basically take and arrange all the data according to years. And now we'll get the lower extreme values and upper extreme values. We'll get all the what are the maximum and minimum values of different dates. This is the monthly average prices. 1 minute, give me a minute. This is the monthly average prices of potato commodity. As you can see, the price is directly increasing and decreasing according to months. We are not taking every day. We are considering it as one monthly. And this is moving average plot. Next, it will be seasonal decomposition plot. As you can, as Ashwin has said, explained earlier in the PPT, all the values are from 1500 to 2000 observed values. The trend is from 750 to 2250. Seasonal trend is 0 to 5, and residual data is from 0 to 250. And after this, we'll go to ARIMA model. Here we are executing all the values. We'll get first the Serimax values, and then we'll directly calculate the AIC values. And this model basically takes whatever the smallest AIC value will be there, it will directly take it. And it will be the best predicted values. And from here, we will directly predict the output. I mean, the future prices. This is the Sarimax values. And as you can see, we are printing the summary. All the tables data will be shown here. And we are forecasting validation. The next part will be forecasting validation. As you can see, these are the different types of graphs that we can perform on the future predicted values. The forecasting prices have been already generated, and now we are just till January 2019, all the data will be shown in this plot, and this plot will show us the future prices on a particular graph. Now we'll get the predicted mean. And basically, normally in the forecasting and prediction, we'll test the accuracy by finding the RMSE value, that is root mean square error. So as you can see, the root mean square error is 31.0. So we can get the accuracy around 78. This is the deployment and the program execution part. Thank you.
Hey, thank you guys. Thank you, Ashwin. Thank you, Prithvi. So, friends, do we have any questions pertaining to this particular project, or do you want to ask any questions to the team? Please post your questions. You can post your questions on YouTube chat window. Okay, I see no questions. Wonderful. So, Sushant and Ashwin, great work, guys, and really proud of the product. It's helping a lot of farmers, which is the need of the hour. And thank you, and all the best for the future endeavors, guys. And okay, I have a question here. Yeah, difference bet Jupiter Spider. These are two different applications, Nandu. So you can use any one. One is basically a browser-based UI application. The other one is the standalone application. Yes, Sheikh, the application is already being used by the client, and yeah, it's live, basically on working on live data. And the team size is approximately 8 people, if I'm not mistaken.
Yes, sir.
Okay, do we have any other questions, friends? Great. So I see no questions. Anyways, if you have any questions, you know whom to tap. You can always come back to us. I would be very glad to connect with your team, with the team. and we'll also try and address all the questions that we have. Let me conclude for the evening. Thank you so much, everyone, and yeah,